Hello, everyone. In this lesson, I'm going to talk about solving tangent equation. You have seen solving sine equation and cosine equations. And in those sections, I have talked about the different ways you can solve those equations and how to use arc sine, arc cosine. And in this lesson, I try to make it short, okay? So I'm going to go straight to the topics. And unlike other lessons, I talk about special angle first. But this time, I'm not going to talk about special angles first. I'll be talking about general angles first. Okay. So solving trig equation. Okay. We have done trig function, which is mostly ARD. Solving trig equations such as sine equation, cosine equation, that's from D to A. And of course, we still have our ARD here, which is our fundamentals. And we understand these, the implications, how angles are measured. These are always our essentials. Okay, so I'm going to delete this piece, okay, as it's not really necessary here. And R and D, okay. And briefly just review that sine function is from angle to ratio. It's y over r. Some people like it to use the y over r. Okay, I would honor that. And the cosine is x over r, which is red over r. And the tangent is blue over red. Okay, I use these color coordination in the case that x, y are used for other things. So that may not be a confusion. And of course, the ratios will be these ratios and so on, right? So we can just modify this to like a better ratio expression. Okay, so that those ratios would be these. Okay, just to be familiar, these are the absolute fundamentals. Okay, so I'm going to remove all of these. Do you understand? So this will be simpler. So for sine is y over r or blue over r, and cosine is red over r or x over r, blue over red. That's for tangent. Arcsine, the whatever number after arcsine is a ratio in the form of blue over r. Arc cosine is red over r. Arctangent is blue over red, but arcsine takes ratio, produces angle. All of these angles, they have their specific range, and all of these ratios have their specific domain. So that was summarized in previous lessons, so I'm not going to repeat. So today, we're going to talk about specifically just tangent, okay, just tangent. And so I'm going to just delete these two, delete sine, cosine, okay? So we just be very specific about tangent and arctangent. Okay, so that's nice and clear. Solving for angles, we're solving for A. Okay, so this is going to be D to A. Okay, we're going to take the example of solving tangent equation. Okay, this one tangent equation, I have the equation given. They will say solve for A or solve for X, right? And the ratio we're given is a 3 over 4. So the form of blue over red, okay, or arctan of y over r, y over x. Okay, so we are basically given y over x. Okay, and we know algebraically to get a 3 over 4, y could be 3, x could be, so think about algebraically what y and x could be. It will, result in a ratio of 3/4, right? So it could be 30/40, right? 30/40. It could also be -3/4. Okay? So these are the possible values of y's. So y could be 3. If y is 3, x will be 4. If y is 30, x will be 40, right? If y is -3, x will be -4. So you see it from that perspective. So this way, from that, we drew this picture. So what I draw here is that this will result in the same line. This will result in the same line, right? 30/40, the same as 3/4. So I'm just going to remove that. So simply, we have two pairs of points. One is x is 4, y is 3 from here. And the other point would be x is -4, y is -3. These 2 points makes the point, right, in the definition that x comma y, that's the point we call x comma y. X comma y, so basically let's put these numbers in place. So basically for 4,3, so this is 4 and that's 3. Okay, and this is -4 and it's -3. So when we talk about DRA, we have found our R, right? This is the reference angle. This is the reference angle. This is another reference angle. Reference angle is positive. So let me erase it. Okay. Reference angle is positive, right? So this is reference angle and this is reference angle. Okay, we found the terminal. This is the part that from D, right? So this is a D. The information we are given is D. From D, we found the reference angle. So we found this the terminal. We found the terminal. We got two terminals. So we got R. And the next one, of course, we'll need to find A. Okay, so we're about to find A. So you can see how we find the terminals. Okay, so now let's erase, clean up, right? No, I'm not going to clean it up. It's just keep it here. We're going to find the terminal. We're going to find the terminal. How do we find the terminal? Okay, so let me use a color that's most agreeable. Okay, we're going to find the angle that will terminate at the terminal we have identified, right? So we're going to measure, if we measure this way, and this angle is right in the range of arctangent, right? Do you remember what the range of arctangent? The range of arctangent, very important piece of information, okay, is between -π/2. We have talked about that. So now it's time to use it. So arctan of anything, okay, the domain for arctangent is all real numbers between -π/2 to π/2 exclusive, okay, between -π/2 to π/2. This is the range. So this angle is going to be in the range of arctangent. So we're going to give it a name. Okay, what name shall we give it? We're going to call it theta. Okay, so let me mark it. So this is theta. Okay, So this theta, we're going to define it as arc tan of 3/4. Arc tan of 3/4. So this is the angle. Okay. So any angle terminates here will give us all possible, well, will give us a lot of solutions. Okay. And let's look at the other one. Let's look at the other angle. Hold on. Wait. Sorry about that. So that's about the two software don't talk to each other. Okay. So that's theta. So any terminal that terminates there. So I'm going to put the arctan range in here. It's a very important piece of information. You're going to use it in calculus 1 as well. So we're back here. So this is one terminal, but there's another terminal, right? There's another terminal. How do we measure the other terminal? The other terminal would be measured from the standard position over here. But we also notice that these two terminals are on the same line, meaning that if we get theta plus pi, we will get to the other terminal. Plus another pi, we'll get to this terminal. And so keep adding pi, right? Adding another pi. So our solution can simply be expressed as A, okay, is equal to, right? All of the solutions we're looking for. It will be theta, theta plus k pi. K pi means 1 pi, 2 pi, okay? And that's all the solutions, okay? So let me show you again, okay? So I'm going to clean this up. Clear all drawings. Let's see how the solution. So now we have the solution, right? That is theta, right? Once we get theta, this is theta, right? Theta plus 1 pi, right? Plus 1 pi, right? If k equals to 1, we get to the other terminal. So the other terminal is covered by this expression. If I add another pi, so theta, that's plus another pi, we get to the terminal in the first quadrant. If I add another pi from here, so this will be adding another pi, right? And from this piece, we're adding another pi. So we keep adding pi, we will get all the solutions possible. Then you say, can I subtract pi? Of course you can subtract pi, right? So suppose I reach here, that's my theta. Then if from here I subtract pi, I get to the other terminal. Minus pi will work too, right? And from here, if I subtract another pi, this is going, clockwise, and minus another pi. So k be any integer, and here we have found all possible solutions. So you can see the solution for tangent is very simple, okay? Just plus k pi. K is any integer. K is an integer, okay? Or you can also replace theta by arc tangent of 3/pi. In that case, you don't have to introduce theta, and we're done, and we're finished. Okay, so that's how to find the solution to a tangent equation. Okay, so let's clean up. Let's look at another solution, another equation. Okay, same thing here, but this time we're given the ratio is -5/12, right? So how do we identify the x and y, as a, this is what we know it's y over x, right? It's y over x. To get a ratio of negative 5 over 12, it could be negative 5 over 12, right? Or it could be positive 5 over negative 12. So this way, right? This way, we got two possible xy's, right? So one possibility would be, y is negative 5, x is 12. So 12 comma negative 5. And the other one would possibly be negative 12 positive 5. So these are the two possible xy's. Okay, x comma y. So we got xy. We're going to have two terminals. So here we go. We got our two terminals, right? You can see 12 negative 5, which is right here, right? And the other one, so let me put it on this side. Right? And the other point will be negative 12 comma 5. So red, blue, red, blue. So, and we have two terminals. Okay, so how do we express solutions? Well, all we have to know is one of these angles. And we're going to choose this is simpler angle, and this angle can be expressed by arctangent because it's right in the range of arctangent. Once we identify this terminal, which is plus pi, or this is subtract pi, or minus another pi, and we plus k pi, same idea, okay? So now, let's express our solution. Okay, so our solution would, we would express it as, if you like to, if you don't have to use it, right? So angle A, okay, which is all possible solutions, can be represented by arctan of negative 5 over 12, okay, plus k pi. And you're finished. Okay? And k is any integer. It could be positive or negative. The argument is the same. Any integer. Okay? So by this time, we need to understand that theta, okay, theta is it's measured clockwise. It's a negative angle. Okay, so let me show you the solution, right? What does this mean? It means, okay, we first identified this is our arctangent negative 5 over 12. We can call it theta. Okay, so let's write down. Okay, since I mentioned the theta, so it's just easier to write it, right? So theta equals to arctan of negative 5 over 12. That would be the theta we're getting. Okay. And then we're gonna what does it mean by plus k pi? Plus k pi could be from theta, we add a pi, okay? We add a 2 pi, we add another pi. It's still on the terminal of our desire. We add another pi, right? Or we're gonna subtract a pi. We can do that, minus a pi. So you're really just bouncing back and forth between these two terminals. And that's, we will be able to find all the angles that will have the tangent angle equals to negative 5 over 12. Okay, so this is the basic method. If you understand this basic method, then you can do anything, solving tangent equation, right? So then you say, what if I have a special angle? What if you have a special angle? That would be great, right? If we have a special angle, in the case of tangent A, what do we get? Well, we can deal with it, right? So this would be y over x. So the possible xy's could be, could be -1 over -1. It could be +1 over 1, right? So and then you get 2 points. One is 1 comma 1, and the other one is -1 comma -1. You got 2 points, and you basically have this point here, right? You have a point here, you have a point over here. Or, I don't know how well you guys remember linear algebra, right? If you know linear algebra from this equation, okay, from this equation, you have y over x equals to 1. That will lead you to y equals to x. You just multiply both sides by x. And that's a line equation. This line equation is this one, okay? This line equation, basically, this is the line equation right here. So you don't have to plot those points. You don't have to plot those points. But plotting these 2 points is not difficult, right? So if you plot those points, no problem. No problem. You can plot these 2 points. You can say, hey, there's a 1 comma 1, and there's a -1 comma -1. So you get those points. By the way, you would have identified the 2 terminals. And well, we obviously know this is a special angle, right? This is a special angle. So how do we express this angle? Well, this angle is arctangent of 1. Arctangent of 1 is pi over 4. You already know. I'm sure you're telling me, hey, I know that's pi over 4. That's wonderful. So instead of writing theta equals to, instead of writing theta equals to arctan of 1, which equals to pi over 4, you can just use pi over 4 directly. So you just remove all of these, right? So this is a pi over 4, right? So this is a pi over 4. And a pi over 4 plus a pi, right? Plus a pi, you get to the other terminal. If you plus another pi, plus 2 pi, you get to the first terminal, in the first quadrant, right? You can subtract your pi and so on and so forth. So in this case, our solution, let me just clean this up. Okay, let me just clean this up. So you got it. Okay. And our solution would be A equals to over 4 plus k pi. This is one of the simplest solution. Okay, why do I say this is one of the simplest solution? Because there's all kind of forms. You can write 5 pi over 4 plus k pi, right? 5 pi over 4, you can do that. So there are different ways to express. The way to express solution is not unique. Okay, so be aware of that. All right, so in the special angle case, okay, so let's do one last one. Okay, I promise you I want to keep it short. And this one, of course, corresponds to a special angle as well, right? So how do we compose the point, right? It could be √3 over 1, right? It could also be -√3 over -1. That would result in the same tangent value, right? So this is where we got the D. And then we have identified the terminal. We identified the terminal where you can also use the line equation thing I was just telling you, right? So that will be, you get a line equation of y equals to root x, root 3 multiply x, right? So this is a line. Or you draw these 2 points, either way, okay? So these 2 points would be, the y is root 3, right? Y is root 3, 1 comma root 3, or negative 1, negative root 3, right? So we got 2 points. So these 2 points are, if you use the point method, these points would be, hold on, let me make it a little smaller because we don't see as well. Okay, we don't see as well. Let me just mark the points. Okay, the points are, one is 1 comma root 3. So 1 comma root 3, there's a point here, a negative 1, negative root 3, right? So either way, you can just draw the line. So you get these 2 points because in ARD, we can pick any points. Remember, we can pick any point. So we just pick up these 2 points, no problem. And then we identify the angles. Then you're going to tell me, hey, that's root 3, pi over 3. And here we go, which is plus k pi. Okay, so now in the end, our solution is pi over 3 plus k pi. Okay, so once again, k is any integer. Okay, any integer meaning it could be plus 1, minus 1. It can be 0, right? When k is 0, you just get pi over 3. And then you can just keep adding as many, many times of multiples of pi as you wish. You get to the terminal, so that will cover all the possible solutions. Okay, that's all for this lesson. Thank you for watching. And let me know if you have any questions.